Hey folks, thanks for coming. My name is Andrew Seigner. I'm a software engineer at Buoyant. I'm here to give this talk with my friend Frederic. We kind of wanted to showcase Linkerd and Prometheus and how they're complementary technologies and kind of show off the latest and greatest features, but also talk about kind of the origin story of how these tools evolved, how we ended up with these features, and kind of how the integration between the two developed along the way. So with that, Frederic Branczyk.
Okay, so first we want to have a quick run through Prometheus. Quick show of hands. How many people know about Prometheus? Awesome, I think that's like 95% of the hands. That's pretty good. But specifically, I want to talk about a couple of features that make it such a great fit for Linkerd and Prometheus. But first, let's talk about some history just for everyone to know where Prometheus came from and how it developed over time. So Prometheus was initially created at SoundCloud by a couple of ex-Googlers who knew some systems within Google, and they liked it, but there was nothing out there. And so they created, they knew Borg within Google, and there was Borgmon, which is the monitoring system, and sadly nothing is named in the open source after the Borg or anything in Star Trek, unfortunately. At least I'm sad about that. So they created this, and today, fast forward like 5 years since they publicly started speaking about it, a ton of companies are using it, and I just saw 95% of the room like raise their hand that they know about Prometheus, and maybe another quick show of hands, how many people are actually using it in production? Okay, that's probably like 60, 70%, so that's great. And I'm hoping that maybe the gap between the 95% and the 70% are going to be running Prometheus after this, and we can add your company to this slide. So let's start with a really simple intro to how Prometheus works on a really basic example. So Prometheus is a pull-based system, so in some regular interval, it will go to your application and grab the metrics that your application exposes. And it just does that via an HTTP call. So we just have an HTTP endpoint on our application that exposes these metrics. And we instrument our application to, whenever something happens, to increment, for example, our metrics. And Prometheus comes every 15 seconds, that's the default, but it's configurable. And whatever our application returns, we add the timestamp to it and write it into our internal time series database. And in this case, our process hasn't actually received any traffic itself, so the request count was 0. But now we're actually routing production traffic to it, and over time it increases its metrics internally, right? And so, for example, now we have 2 requests that were hit against this service, and Prometheus, the 15 seconds have elapsed again, so Prometheus comes around and scrapes the metrics and inserts it into its time series database. And Prometheus just does this forever and eternity, and this is essentially the example of a single time series from one target. And we'll keep reiterating on this terminology to guide us through this talk, basically. So what we just saw was collection of time series data, but Prometheus is a monitoring system. Now, what does that actually mean? For something to be a monitoring system, at least in my point of view, it means that we need to be able to do something actionable with that data that we're collecting. And I think the best example of that are alerts. So if there's some condition in our system, then we want to get a page, for example, or a Slack notification or something that tells us that there's that something's off in our infrastructure. And I just wanted to show that there's really nothing that's like black magic in Prometheus. Like, we saw that the collection is super simple. It just every 15 seconds it goes around and collects all this data. So that's really simple, right? And alerting is really the exact same thing. And you see this throughout the Prometheus code base, that really everything's like super crisp and just pretty, I don't want to say stupid because it's good, but it's stupid as in it's simple to understand. So yeah, this also just happens every 15 seconds. Prometheus just evaluates all the rules it's configured to evaluate, and then if an alerting rule is firing, then it will actually fire that. But now we're at KubeCon, so what does that have to do with Linkerd and Kubernetes and Prometheus, all the CNCF projects? So Prometheus has built-in service discovery mechanisms for Kubernetes, and what that means is Prometheus can go to the Kubernetes API and ask for all the pods in your Kubernetes cluster, for example. And that way, Prometheus then knows, okay, I have this pod, and goes ahead and scrapes all of those individually. And this is a really subtle but very important thing, which is Prometheus is about Whitebox monitoring. And that actually does mean that we do go to every single pod and want to grab metrics from every single instance. We don't load balance this or something, because then we would be getting metrics from different processes every time we scrape our metrics. We actually want the granular targets to be scraped, and that way we have true insight into our applications and how every single process is doing. And then we can do aggregations over our entire infrastructure and make sense of all of this data. So this is really important when you think about Prometheus. We always want to make sure we get data as close to the origin of some action. So if we are talking about a network service, we always want to have the instrumentation as close as possible to the code that actually does the network requests. So let's visualize this a bit. So we saw previously we had like a table where we inserted all of our timestamps, but it turns out time series are actually nice for graphing, right? So we have a couple of samples here, and we have a metric called HTTP requests. That's a really common thing to have, but Prometheus has a model where you can basically enrich all of these metrics with additional meta information, which are labels. And in this case, for example, we don't only have one series for HTTP requests, but we have lots of series describing different aspects of our HTTP server. So we can have, for example, metrics based on request paths or on response latencies. All things like that are totally possible with Prometheus. And we'll see later how that's great with Linkerd. Now, Prometheus was created at a time where there was no Kubernetes. And at the time, the engineers looked at what is the lifetime of a time series. And typically, things were deployed on virtual machines, for example, and all processes, even if they were restarted, they would be restarted on the same virtual machine, and everything would basically stay the same. So that means that our time series were always continuous. We didn't have lots of time series that started and stopped. Now this changes dramatically on Kubernetes, or even on cloud providers that sometimes start to evict your virtual machines or stuff like that. So it's super important that Prometheus is purposely built for an environment like this, and this is what we did when we created the Prometheus 2.0 storage. We specifically had this problem that there were lots of pods coming and going in Kubernetes, and that meant there are a lot of time series that keep being created and stopped. And to make that problem even worse, people like insight, and that's a good thing, but it also means that it's that much more data. So the more labels we have, the more time series we're going to produce, the more load we put on Prometheus. And essentially the most costly operation is creating a new time series. You can roughly compare that to creating a new file that's relatively expensive, compared to appending to an existing file. That's a pretty cheap, or at least comparatively, a very cheap operation. So what's our situation? We are in a world where targets come and go all the time, and they expose hundreds and thousands of time series at a time. So when we realized this in Prometheus 1.x, we just thought we completely had to rethink everything that we did, because one of the key things in the Prometheus 1.x storage was that every single time series was a single file on disk. And if you think about millions and millions of active time series, that translates to millions and millions of files on disk, which some file systems are not even particularly happy about us doing. So we completely rewrote the entire storage engine, and the problem is not just inserting this data, but then people also want to do queries, all sorts of queries. And basically we have a visualization here that shows we have all sorts of queries where we slice and dice data, and we want all of this to be fast, right? And all of that is possible with Prometheus 2.0. And another cool feature that I think is pretty unique about Prometheus in the space, because Prometheus is pull-based, it can immediately detect if a time series goes away. So if our /metrics endpoint had metrics for some path information, and that went away, then we can immediately tell in Prometheus on the next scrape that this time series has stopped. Now this is not particularly useful for HTTP requests, but if you want to have, for example, in the Kubernetes case, we often have that pod information comes and goes all the time, and we want to be able to tell that the pod has disappeared immediately. So staleness is really how can we tell that a time series is done? And previously in Prometheus 1.x, this was just like a timeout-based system where if a time series hasn't received a new sample within the last 5 minutes, it's marked as stale. But that's problematic because that means that it potentially takes up to 5 minutes for alerts to actually register that this time series is done. So that's too late. And in Prometheus 2.0, what we did instead is immediately when we have some tracking functionality, and immediately when the time series disappears from the endpoint, we immediately mark it as stale. And this is a really nice property of Prometheus being a pull-based system, because in a push-based system, this is not really possible unless the pushing target also knows when it ends time series, which is kind of difficult to do. And this is really great functionality, and it actually made us discover a bunch of problems in the Prometheus ecosystem, because this is an example of CAdvisor, which exposes metrics about containers, and there was a bug that wasn't actually that was causing CAdvisor not to actually continuously expose metrics, but just have gaps every now and then. And in Prometheus 1.x, this looked totally fine. We have continuous lines, everything looks happy, but in 2.0 with correct or better staleness handling, we immediately noticed that there could be a problem. And as I said, this is super important in order to be sure that the data that we're looking at is always fresh. And even if you go out of the talk not remembering any of the things that I've just said, then just remember basically this slide. Prometheus, a single Prometheus server can get you really far. And we've seen in the wild, in actual production systems, that Prometheus is ingesting over 700,000 samples a second. Prometheus is capable of doing more. We've done this synthetically, but this is like one of the, an example in the wild that we've seen that real production, in real production usage. Usually people then start to split up Prometheus by responsibility. So you have one class per Kubernetes cluster or per namespace or something like that. And 700,000 samples per second roughly translates to a 350 node Kubernetes cluster. That, of course, is like a generalization because it depends on which metrics you collect. But 350 nodes Kubernetes cluster is already, you can already run quite a lot of workload on that. And now we'll see, we'll hear from Andrew how all of these features in Prometheus make Linkerd that much more awesome.
All right, thanks a lot, Frederic. So yeah, what I'm hoping to do is kind of walk through a similar history of how Linkerd evolved. There's actually a lot of parallels with how Linkerd 1 and then 2 evolved along with Prometheus. So to give a little bit of a background, so Linkerd is an open source service mesh for cloud native applications. What does that mean? So service mesh is a term for a layer of software that provides security, reliability, and visibility to your microservice architecture. And so there's typically two components of it. You have a control plane, which is really like the operational view of what's going on. So that's a place where Prometheus would live. You collect metrics. It gives you some kind of a user interface, either through a dashboard or through like a command line interface. And it's providing service discovery to your cluster, and it's also gathering metrics. The other side is the data plane. That's typically a proxy that's running as a sidecar next to each of your pods or your containers in your application. So to back up a little bit and kind of figure out like how did we get here, Linkerd's origins go back to Twitter in 2010. At that time, it was probably the largest Rails installation on the planet. The summer of 2010 was the World Cup. Every time Brazil scored a goal, everyone would tweet goal, and the site would crash. And so we were frantically trying to decompose this thing into microservices. And we found that every service kind of needed the same thing. It needed security, visibility, and reliability. And so we factored that logic out into a library called Finagle. It was a Scala library, which is still used probably in every microservice at Twitter today, or virtually every service. And it's gained pretty good acceptance across the community. I think even SoundCloud maybe uses it. And so it was great. We found it very useful. The drawback was, since it was a Scala library, you needed to be writing a Scala application to take advantage of this kind of thing. So that was kind of the inspiration for building Linkerd. What Linkerd 1.0 did is it took this Scala library and wrapped it into a proxy, so that any language, any framework, you could be running locally, you could be on Mesos or Kubernetes or whatever, you could take advantage of this like service mesh concept, and it was agnostic to like what technology you were using. So about a few months after we released Linkerd 1, we started getting requests for integration with Prometheus. And so we added this endpoint, as Frederic mentioned. Prometheus is a pull-based system. So all we had to do was expose this nice little metrics endpoint on Linkerd, and then Prometheus could go around and collect metrics from all the Linkerd proxies running on your cluster. At the time, that's kind of all we provided. We started building up some examples, some kind of reference designs on how do you plug Linkerd into Prometheus, and we realized that those reference designs started getting a lot of attention, needed a lot of support, and that kind of motivated us to start thinking about a tighter integration between the two. And so fast forward to about a year and a half ago, and we started thinking about Linkerd 2, and we kind of made the jump to do like a complete from the ground up rebuild. And I'll walk through a few of the motivations for that. One was the Kubernetes ecosystem. The like excitement around this community is insane. Like the crowds in these rooms is wild. And so while Linkerd 1 kind of, you could run it anywhere, that was great, but the downside is it made configuring it super complicated. You know, you had to come up with a pretty complex config file, and it was not like an easy out-of-the-box set it up and go. And we're gonna see how Linkerd 2 does that. So targeting specifically Kubernetes made configuration like orders of magnitude simpler. Next, we wanted to include Prometheus as a first-class component. So rather than walking people through plugging their Prometheus into Linkerd, we'll just give it you fully integrated. If you wanted to bring your own Prometheus, you totally could. It's all open source, but out of the box, we just wanted this stuff to work, and we'll see that in a minute too. The other pieces were which technologies did we choose. Scala served us really well for a long time, but when you're trying to run a proxy on next to every pod and people are like, writing little tiny services in Go or whatever, and they take up 10 megabytes of RAM, and we're asking you to install like a JVM process that requires 200 megs of RAM to run right next to it, that's not really acceptable. So for the control plane working in the Kubernetes ecosystem, Go seemed like a natural choice. The community, there's a lot going on, and it plugs really nicely into all the Kubernetes tooling. On the proxy side, we made a bit of a bet, and we went with Rust because we wanted that native performance, but we also wanted kind of the safety that we were used to from Scala. And I say it was a little bit of a bet a couple of years ago, but I think it's proved out pretty well. We've gotten great community support, and we've even hired some of the members of the community to work on libraries that help support the Linkerd proxy. So just super high-level overview of how it works. This is kind of that same diagram you saw a minute ago with a control plane and a data plane, and you've got your Linkerd controller, that's the Go side, talking to Kubernetes. Very similar to how Prometheus works. It's getting all the service discovery information. It's telling the proxies where all of the pods are. And then next to every pod in your cluster, you've got a little Linkerd proxy running. And that thing knows how to intelligently route to different pods in your cluster. So this is a really similar pattern. As I said, Prometheus is a first-class component of Linkerd 2. It's set up to also listen to Kubernetes, while Linkerd is doing routing information based on what Kubernetes is telling it. Prometheus is doing collection, as Frederic mentioned. So it goes and asks Kubernetes, where is every Linkerd proxy running? And then it goes out and it collects data from every Linkerd proxy and lets us roll up that information. And because that proxy is responsible for every request in and out of all of your applications, you can get everything from request load, latency, success rate, Linkerd is protocol aware, so you can get things that are HTTP or HTTP2 specific or gRPC or whatever you're using. A little bit more, if you just want to introspect the metrics themselves, we also included Grafana. That was another lesson. Like, people kind of wanted all of this stuff integrated together. So if you're familiar with using Grafana in Prometheus, like, if you install Linkerd, you will feel right at home right away. That stuff will work out of the box. And then to administer that control plane, we also include a CLI and a dashboard, and we'll kind of run through some of those tools in a moment. So I'm going to attempt a bit of a demo. We've got a really basic app made of 3 microservices. It's intended for managing your bookshelf. So you've got a front-end web app, and you've got a book service behind it and an author service behind it also. They're talking to a MySQL database. Each of the 3 microservices has 3 replicas, and we'll kind of see how they all interact. We've got a traffic server or a traffic instance that just is meant to put load on the system just to make the data interesting. We'll also look at the Books app from a browser and make sure everything's working. And then we'll also deploy kind of a chaos monkey script that'll start tearing it all down and kind of demonstrate how Linkerd and Prometheus handle that. Frederic was mentioning churn, and you're in this orchestrated environment, things are coming up and down. How do these tools perform when that's all going on? So the first thing I'm going to do is deploy my Books app. So if that all went right, I'm spinning up 9 pods plus something from MySQL plus a traffic server. So we're just going to take a peek at it really quick. Okay, so here's our Books app, pretty simple. You can click on books, you can click on authors, you can edit things, pretty basic stuff. Shout out to N.K. Jemisin, 5th season, good book. So that's kind of that. Now we're going to do a quick install of the control plane. As I said, Linkerd 1 was super complicated to set up. when I want to install Linkerd 2, I should have mentioned I'm using a Linkerd 2 CLI that I've installed. If you're familiar with kubectl, you'll feel right at home. It's got tab completion. It's got a bunch of commands. You interact with Kubernetes objects the same way you would with kubectl. So if I want to install it, I just run Linkerd install, and I pipe that into Kubernetes. And if you want to kind of get a look at like what that's doing, you can just type Linkerd install, and you can see this is the YAML for the control plane. And if I wanted to look at the different options, you can set, like, there's same defaults and all of that, but of course, like, it's super configurable. If you wanted to set different ports or edit the YAML yourself, like, you're totally free to do that. So if we kind of wanted to look at all the components, everything gets installed into a Linkerd namespace. So you can kind of see everything that we just put on. You can see the 4 components of the control plane. We've got our controller, Grafana, Prometheus, and our front-end web dashboard, which I'll show you in a minute. And if I want to make sure that everything came up correctly, we've got a check command that boots up and checks that all of the different components of Linkerd are up and running. So if you install Linkerd and something's weird, this is the first thing we will tell you to run, and it should give you a nice little report on what's going on. So we're good. So next up, I want to show you the Prometheus that's inside the Linkerd namespace. So let's take a look at that. Port forward, service, Linkerd, Prometheus, 9090. So for those familiar with Prometheus, this is, you should recognize this. The interesting part is how Prometheus is configured to collect metrics. The 2 jobs I want to point out are the Linkerd controller. Those are our control plane like Go components that we're collecting metrics from. But more importantly, we're collecting from the Linkerd proxies that are running inside the control plane. So we use Linkerd in Linkerd. We have all of these Rust proxies that are running inside the control plane itself. As you start to deploy Linkerd into your apps, that list will grow, and you'll see Prometheus start to pick up the proxies running in each of your apps. So now I want to show you the Linkerd dashboard just to kind of give, you can do all of this from the command line, but it's also nice to just kind of be able to browse around and see all the information. So you can see here, we're getting metrics on the control plane components, and this is the same way that you would get metrics on your own app, which you'll see in a minute when I inject into the Books app. As I mentioned before, if you just want to use Grafana and talk directly to Prometheus and click around and see things like success rate, request rate, latency, it's all here, and we'll dig into this a little bit more. But yeah, kind of the point was like this all comes up like without a lot of setup. So the next thing we're going to do is we're going to inject Linkerd proxies into the Books app. So let's just kind of make sure that the Books app is still here. I can still click on it. It's still running. Nothing up my sleeve. So we're going to take that Books app YAML that we had before, and we're going to pipe it into a Linkerd inject command. And all that's going to do, and then we'll pipe that into Kubernetes. And if I kind of want to look at what just happened, it took our application YAML and injected several Rust proxies into it. The app, if we did this right, should not have gone down. You'll see some pods are spinning up, other pods are coming down, but the app should continue to work without issue. So I can refresh it, I can still click around, and everything continues to work. So if I go back to my dashboard, if things worked as expected, I should start to see some telemetry information of the Books app that I just deployed. And you can see we're already getting success rate, request rate, latency, all of that stuff. And I can click into like a Grafana dashboard again and see all of the same information for this book service. So if you take away nothing else from this talk, in addition to this 700,000 requests per second for Prometheus, know that like without changing your app at all, you can run a Linkerd inject command and get metrics like this for free without doing a single thing. You don't have to tear it down. We specifically targeted Linkerd to run in a number of different environments. So even if you're not a cluster operator, you can't even create namespaces. You can still install Linkerd and inject it into like your own namespace that you have control over. To dig into a little more data, if I wanted to look at stats for all of all of the things that are running. Here's my different deployments in the Books app. I can also do it over namespaces. Again, if you've used kubectl, you'll recognize all of these. If I wanted to filter from one deployment to from maybe all deployments into, let's say, the author service, I can do that too. So again, really, we try to make these patterns very familiar. We also have a tap command that allows you to tap into every request that's running through the system. This isn't like tailing a log. This activates a gRPC connection and starts streaming data from the proxies dynamically, so it's only doing work when you're running the tap command. You can obviously filter this a bunch of different ways to kind of identify requests that are flowing through your system. If you want a slightly more rolled up version, we have a top command that'll give you, it's a lot like top on your laptop, but it's like a top for microservices. So it shows all of the requests that are flowing through, but in a rolled up way. Now, Frederic mentioned earlier the cardinality issue with Prometheus. It can ingest a ton of stuff, but it's not really appropriate to abuse it as far as putting a lot of different time series into it. And you can see here, like in this list, some of the requests we're seeing have path information. And a URL that includes like author/168.json, like that's not really appropriate. If you have thousands or millions of objects in your database, and it wouldn't be right to like record metrics for each one of those. So we need a way to kind of roll that up. And I should kind of jump back and say like the motivation for this talk started in a tweet almost a year ago when we announced like kind of our first beta version of Linkerd 2. At the time we called it Conduit. And Frederic very politely replied and said, I'd like to talk to you all about your Linkerd story. And he's really provided some awesome guidance on kind of creating best practices integration with Prometheus. So part of what came out of that was fixing that cardinality problem so that we can kind of get metrics in a well rolled up way. So inside my Books app, I've also got a bunch of Swagger documents that describe the APIs of each service. And with a new Linkerd profile command that we've recently added, I can convert that Swagger document into a CRD that Linkerd understands, and then pipe that into kubectl. I'm going to run another command over here just to kind of demonstrate what's going on as I'm deploying these CRDs. All right, cool. So there's a Swagger document for the books, the author service. I'm going to do it for books. And for the web app. Okay, so we already see that our metrics are starting to get rolled up in a way that is aware of our APIs, which you can get here. You can get, if I jump over to the Linkerd dashboard, I should be able to drill into the deployment of my author service. I can kind of see what's calling it, what it's calling. Here's kind of the exploded view of all the requests, but then here's the nice rolled up view that's, again, aware of like the design of my API. If you don't have Swagger documents, you can define these CRDs yourselves. It's pretty flexible. The last thing I'm going to deploy is a Chaos Monkey script. So this is going to, I mentioned we have 3 services with 3 replicas each. That's 9 pods. This thing is going to randomly pick a pod every 10 seconds and just tear it down. So you'll start seeing the pods bounce up and down. And kind of the point in how Linkerd and Prometheus integrate with Kubernetes is that because they're getting real-time information from Kubernetes, your applications should continue to work okay, and your metrics information will continue to be like, will be continuous, correct, and real-time. Like as Frederic mentioned, having like a 5-minute timeout when your pods go away isn't really, it's a much better model to kind of know out of the box, when things are bouncing up and down and still get consistent metrics across that. So quick shout out to, sorry. I just wanted to call out really quickly all the things we just did And hello, computer. Okay, we're gonna look at it like this. So I ran a Linkerd install command to install the control plane. I ran an inject command, didn't change the app at all. We used stat and top to kind of get information about what's going on. We ran a dashboard command to give kind of a high-level browsing overview of it. We looked at Grafana and Prometheus. We ran a profile command to take advantage of Swagger, and we ran a routes command that gave us API-aware statistics about our application. So again, quick shout out to the Linkerd community. It's been in production for over 2 years now. We've had over 100 contributors. There's 2,500 people on our Slack channel. Please come and join. Ask us questions there. Ask us questions at our booth, all that stuff. So on behalf of Frederic and I, thank you all so much.
Questions? Do we have time for questions? Okay. There's one question.
So, good question. Sorry, yeah, the question was, can you get things like OS and container level information? You can do that with Prometheus and Grafana. That's part of Linkerd, or you could install it separately yourself. Linkerd is really concerned with the request level metrics, but we have variations of Linkerd that have Prometheus configured to gather that kind of information. And that's totally something that you could take that Linkerd install YAML and edit yourself if you wanted to. I think it would be up to you whether you wanted to do that in the observability stack that's in Linkerd, or you could do it in kind of your own stack. It's really your choice. Okay. Sorry, say that again? Yeah. Yeah, so the question was, can Linkerd kind of be your one-stop shop for TLS? Yes, we have. When I ran that install command, there are flags to turn on TLS, which will use TLS between all of the proxies. We're working on things like Ingress, that's coming soon, and we're working on including like a full CA. So it's kind of in progress right now, but you can try it out if you download the latest version of Linkerd right now. Yep. Go ahead.
Over here.
So if we did the inject,
Yeah.
do we get zip like tracing, or do we still have to propagate the header to get the whole thing?
Great question. So the question was, do you get Zipkin? So the Linkerd 1 supported Zipkin. Linkerd 2, we decided to drop support for it. We felt that we could get like about 90% of the benefits of tracing by just having metrics about what's calling what. We can kind of build your call graph and give you tracing-like information, but if you really need something like what Zipkin does, where you get a request and you need to see that request transit through all your microservices, you'll need to configure Zipkin separately to do that.
Okay, right here.
So best practices for using Linkerd in really large clusters. Let's say I run a cluster with 1,000 nodes,
Yeah.
hundreds, 1,000 namespaces,
Yeah.
hundreds of applications, and so on.
Yeah.
How many instances of Linkerd I need, and how do I split applications between those instances?
Right, so you can deploy the control plane with a flag that says how many replicas of each component you want. So that number like depends on all kinds of like performance, but it's designed to run in an HA configuration. So if you encounter performance problems with the control plane, you can just scale up that replica count to accommodate your cluster.
But still, you see, with Grafana, for example, monitoring thousands of applications in one dashboard not really useful. How can I split my application between instances of Linkerd and say that this group of developers uses this instance, that group of developers uses that instance? And if you want to, I can spin up another Linkerd instance for a new group.
Okay, that's a good question. So the question's around how could I split up my Linkerds if I have a certain set of concerns for a group of applications over here and another over here? When you run that Linkerd install command and the inject command, you can specify which namespace you want to be concerned with. So you can deploy n number of completely independent Linkerds in different namespaces, and when you go to inject a proxy, you can decide which Linkerd you want that proxy associated with. And then when you're seeing these dashboards and all those metrics, they'll be totally separate.
Okay, thank you very much.
Yep.
Sort of building on that question,
Okay.
Prometheus, do you actually recommend in production running it as a separate Prometheus for Linkerd, or if you're doing something higher scale, would you have a centralized for a cluster of Prometheus that you can feed into?
For the most part, we've configured Prometheus to work very specifically for Linkerd's use case. We don't hold on to metrics for very long. So generally, we'd say, for as far as Linkerd's metrics are concerned, you can run that Prometheus like part of Linkerd. If you wanted to run it, it's your own. You totally can. We have a documentation on our website on how to do that. So I saw you.
Thank you.
Sure. Sorry, say that again?
The Prometheus operator CRDs, is it available in Linkerd?
So the question was, is there like an integration story with the Prometheus operator? So for the most part, yes. The specific configuration that Linkerd ships out of the box uses the vanilla Prometheus configuration, but there's nothing stopping you from using the Prometheus operator CRDs to model the same thing. It's just not default. Sorry?
The Linkerd itself deploys the Prometheus, so already a Prometheus operator is inside the Prometheus cluster.
Right. You could, as Andrew said, that you can totally run your own Prometheus, and that could be through the Prometheus operator to be used by Linkerd.
And do we support the Prometheus federation also?
I mean, at the point where you run your, sorry, the question was, can you use federation in that kind of setup? At the point where you run your own Prometheus, you can do whatever you want, right? Like the only thing you need to be careful about is that you basically use the configuration that Linkerd uses, and then you can do things like sharding based on that configuration, which is something that Prometheus supports. And then you can do federation, or you can use something like Thanos for horizontally scaling everything. Yeah, all of that is totally possible.
So when you do the Linkerd inject, you injected a sidecar with the security policy of NetAdmin.
Yes.
From a security standpoint, that's a big no-no, because now any bot can go and inject and mark the IP tables.
Yep.
So what's your answer to kind of secure that?
Yep. Okay, so the question was, someone astutely noticed that one of the containers we inject with the proxy requires netadmin privileges. What's going on there is we have two pods. One is the proxy itself. The other is an init container. Those init containers are changing IP tables to manage that. We have an open ticket right now in the Linkerd repo to support inject without a netadmin privilege. I don't have all the details for it, but it's in the repo. It's open source right now. You can take a look. And if you have particular requirements, like search for netadmin in the repo, like and comment on the ticket, please. Yeah.
On his question,
Yeah.
have you looked at more like node level Linkerd instead of like sidecar patterns as like a, especially with like low mobile services coming up in Kubernetes?
Yeah.
I know Kubernetes has gaps to make that work better, but
Yeah. So the question was, have we looked at configurations of Linkerd that run kind of per node rather than as a sidecar? It's interesting. Like Linkerd 1, that was kind of our default pattern, and so it's something you could configure Linkerd 2 to do. We don't have a lot of reference designs on how, but it is something that we're looking at. So everything you saw online is available in open source. So obviously, like Linkerd is totally open source. You can see all of it. We have a Linkerd examples repo that shows a lot of the examples I was working through. And if you just look for like Buoyant Books app, you're going to find the Books demo. You could run through everything we just did. Yeah, totally. This was all like self-contained Kubernetes on the laptop. Okay.
I got a question. Linkerd 2.0 it doesn't support like a network enforcement policy like in Istio, and can I make a like TLS connection between service A and service B?
Yeah,
Because
so-
this is what I couldn't find on the documentation because
That's
I
right.
tried to play around 1.0 to 2.0, but I couldn't find it.
Yeah, so the question is, does Linkerd 2 support network policies? It does not today. It's on our roadmap, and it's a,
I have to rely on CNI like a Cilium or Calico and do and a low.
for now, yes. It's definitely something we want to support. We very intentionally been releasing a smaller set of features and trying to get those production ready and then expand, but that's on a short list.
What about TLS connection? So far I didn't make like service A and service B speak with like.
We do support TLS connections between the proxies, so you can turn that on. But we have a lot more work to do there, particularly for Ingress. So again, there's probably open tickets in the Linkerd repo to like we're gathering requirements for right now. So please take a look in there. Yeah.
Okay.
Cool. One more.
I'm looking to potentially install Linkerd 2 with Helm
Yeah.
in the future, and I know there is like a PR open right now for that. I was just wondering if there were any like new updates on that.
I know there is some like Helm charts out there that support installing Linkerd 2, I believe. I haven't worked on them, but if there's an open ticket, I definitely recommend commenting on it. It's something we do want to support as kind of a first-class way to install it.
Yeah, I think the issue is that like if basically what would be generated by the template changes by the CLI, then there'd be like an issue.
That's right. Yeah, similar issue. We've recently added, a community member added auto injection capability, so you can install your control plane like through Helm and then set everything to be auto injected, and then anytime you deploy an app, it gets proxies for free. So, yep. Cool. Okay. Thank you.